Alright, so right now I've read through the manual, I've studied, thought about this transmission, and thought about different ways to explain it. And it might initially seem very complicated, but it's actually quite simple. But the thing is, some of the concepts are a little confusing. Okay, and so before anything else, I'd like to start defining those this main concept. And it's I've mentioned it in previous videos, but it's the outer speed, the center speed, and there's the RPMs, and there's the outer speed. Okay, so basically, the best way for me to explain this is get a big grinder. Like, you could even use a table saw, but I mean, don't do it, guys, because if you mess up, you'll cut your fingers. So that's what I'm mentioning. A grinder with a let's say a 7-inch diameter grinder, grinding wheel for metal, right? Because I mean, if you touch the edge and it's on, it'll burn your finger, but it won't cut it off, right? So that's another thing I should start determining, the diameter. And you will need some mathematics here, so get out your calculators and your pencil, because you will need some mathematics here. Fuck, you never thought you need mathematics for a transmission, right? Yeah, mathematics is everywhere, guys. Fuck, we used to say, you know, fuck, I'm not gonna need this shit. Oh, you actually need it, even for a transmission. So the first thing here, diameter is the distance of one edge of the circle to the other, like that, through the center, passing through the center, right? Because if you were to go up here, that would be smaller. But the distance is going through the center, they're the same, right? That's what a circle is. Circle is an object whose outer edges are all at equal distances from the center. Right? You see, they're all at the same distance. So the diameter is a line going through the center, and it's the distance between one edge to the opposite edge. Okay. Now the radius is half of that, so it's from the center to any of the edges. Okay. What's the radius? Once again, the radius is the center, the distance from the center to any of the edges, which is all the same. Okay. So now the thing is, with the grinder, as I was saying, let's say this is a grinding wheel here, and it's turning like that. If I put my hand at the very center, regardless of the speed, it's going to seem that it's moving very slowly, and at the center it is actually moving very slowly. In fact, mathematically, at the very center it has a velocity of 0. But if I were to put my hand here at the outer edge, it's still turning the same speed. Remember, it's still, we haven't changed the speed. Imagine there's the motor here, the grinder is connected here. I haven't changed it. And if you watch one of the other videos, the restoration videos on the Cadillac, I think I actually mentioned that. But if I touch here now, the outer edge, see, the velocity isn't changing. I'm still moving my fingers at the same speed. I'm not changing that. But if I put my finger here at the outer edge, you can see that the speed here is actually a lot faster, right? So on the transmission here, it's turning like that. There, you see, constant speed. I'm turning it, right? If I put my finger here, I won't feel a thing. If I put my finger here, it'll actually hurt. Okay? So that's the basic difference. Okay? RPMs is a term. It means rotations per minute. So full rotation per minute. You know, but we're actually not going to we're going to talk about the concept of RPMs, but we're not actually going to use the actual, per minute. You can have RPH, rotations per hour. You can have RPS, rotations per second. Okay, so we're not actually going to use the actual units That'll just simplify things and make it easier to understand. But that's the concept, okay? Now, why does that happen? Because the outer edge, now if you imagine it's a sphere, a circle like this composed of very smaller circles, you can actually see little lines here. But you know, this length here, this circumference, is actually a lot bigger than at the center, okay? So this is longer. Now all these points, they're turning at the same speed. Okay, so for example, if I put a mark here, across the line here, there you go. Where's my pencil? So I've drawn a line here through this, like that, a radius line, right? Fuck. Here. Radius line there. Now at one full RPM, that you see, let's do one rotation. There, starting from the top, one rotation, okay? Not RPMs, not RPS, just one rotation. Now, if you look carefully, all of the points, the line hasn't moved at all, which means, you know, the circle, this whole thing is moving together. Now, the key difference here, the key concept here is that this outer edge, let's put my finger here. It's actually having to travel a much larger distance than if I were to put my finger here. See, now I'm going to put my finger here more towards the center. See, the distance it's traveling, it's just a little bit. You see? But although this has to cover a greater length, it's going faster as well. So all of them, you know, proportionally, they all arrive back at the same place. Okay, it's impossible for this here to move at a different speed than the outer edge. So once again, mathematically, the circumference of a circle is 2 pi r. Okay, so you just go to your calculator, 2 pi r. So in this case here, I'm going to measure here that's an approximate measurement here from we're going to use centimeters since I fucking hate inches. They're fucking garbage. So 3.5 centimeters. Let's just use 4. Let's say it's 4 centimeters. So 4 times 2 pi, okay, equals 25. Okay, so this distance here is actually approximately 25 centimeters. And another way that you can determine this is you can just get a string. If you don't want to calculate mathematically, you can just get a string. Let me see if I find a fucking string. Or, you know, just anything to wrap around it, and then you stretch it out. You can't measure it with the ruler, right? Because it's, right, the ruler won't bend. I'm just going to get something like this sheet of rubber here. And I can just place the mark here at the edge. See, and then once the mark touches again, then I have my measurement there. See, and that's a full rotation, and now I can know the length, the circumference of this circle. So yeah, it's about, see, it's actually 20 and a half centimeters. But you know, it's just, let's say it's 20 centimeters. Now it's traveling, it's got a longer length, so you might initially think, well, the circle, if it's got a longer length, it's gonna take longer for it to get there. Well, but it's going faster as well. So they all end up at the same place at the same time, if you sort of understand what I mean. It is a little bit complicated, especially in words, you know, you need to study in depth, and I don't want to spend a lot of time on this, but that's how you can measure a circle, by the way. Or in the case where you can't move it, you can just wrap something around it, right? Like that, stretch it out, and mathematics does make it a little easier because you don't have to do that and it's much more precise. But so that's the idea, okay? So now that's going to be important. I'm going to just try to explain a little more. I think you sort of got the idea. So once again, the outer edge, the circumference, okay, it turns at a greater speed, surface speed, okay, than the center. Right, and that's the key difference. Hang on just 1 second. Now on the transmission. This circle, this piece here, this it's called a pinion cage, I believe. Let me just check. Oh, number 13, pinion cage, yeah. Clutch cage. So this big circle here, it's called pinion cage. And the other one, it's called a clutch cam. Okay, now as you can see, this one is smaller than this one. So the outer speed of this one is going to be greater than this one. But they're actually connected together. Okay? So they both turn together, you see? I'm not talking about the outer speed now, the circumferential speed. I'm talking about the rotations. So if this one completes one rotation, the other one completes one rotation. If they complete 3 rotations, they both complete 3 rotations, okay? At the same place, they end up at the same place. See, I can't move them independently. It might seem that I can move this little retaining cage here, but I can't move the cam itself. I believe that's what it's called. Let me just check what's here. Yeah, they have weird names. What's not even a cam? It's not a camshaft. It's just silly names for things. But anyways, and they're splined together, and they're actually connected with this clip. Okay, so they both have the same. They're always together. Now, we can now start our analysis of this transmission. Now over here, I don't know if you'll be able to see it, but see if the motherfucker will zoom in. Yeah. Now you see there, it's triangular. It's got like, forget about this outer clip here. This outer clip. Fuck, let me see the name of that goddamn thing. Number 18. Roller cage. Okay, yeah, that makes sense. That's a good name. Roller cage. Forget about this. Just look at the cam there. You see how it's like a ramp. It's got lots of little ramps. Okay. And what that does is, and you can actually read it from the manual if you want. See, right now, if I put one of these rollers in, it's actually sitting pretty high. See, it's sitting right on top of the crest there, on the ramp, if you will, triangle. Right now, I can't twist it the other way. You see, I can't twist it that way. Won't go that way. Right now, the way you guys are seeing it is, this way is counterclockwise, so it won't twist counterclockwise. But if I twist it clockwise, you see that now it falls to the lowest point, and it's actually now a lot lower. Just notice what that does. You see now it's high, it goes up and moves down. You see, it moves down, moves up, moves down, moves up, moves down, moves up, moves down, moves up. Now what that does is, if the car, it's going to be hard, what goes around it is this here goes around it. This part here goes around this part, the cam. And you'll see that inside is just a circle. Just a circle. I know here there's gears and teeth, but this one goes here onto the pinion cage. But what goes around the not camshaft, fuck. It's a cam, roller cam, whatever. It's the inside there. See, and it's just smooth. There's no teeth. So it's really, this is really cool. The whole car is being moved at high speed just through the pressure of these rollers, okay, against these little 3 angles. There's actually 12 of them, right? But considering moving a heavy car, these cars are heavy at high speed, just through pressure, just through frictional pressure. There's still oil in there. There's oil going in through here. So it's a really, really large amount of force here. So, just consider that the whole car is, resting. It's riding on, it's getting power through these rollers here and these little 3 angles here. These little ramps, if you will. Right? So, this steel has to be really high quality. Because if it's just soft steel, it'll just wear out. Fortunately, on this transmission, the whole overdrive unit was just completely clean, no dirt, nothing. Just the manual transmission side was where there was water, and the gears are a little. The rest of here, there's no problem. You see all the rollers, they're nice and clean, no indentations, nothing on it. Now, what this does is, remember, I'm going to have to demonstrate it with my hand, but when I'm demonstrating it with my hand, just imagine that it's just this circle going around it, right? Now, the rotation here, I went to the car and looking at the fan blade, you can determine if the engine turns counterclockwise or clockwise. In my case, my engine turns clockwise. There are other ways to determine it through this here as well. Now, with these beads here, these rollers, they're facing up. Then they're all facing up, which means they're touching the inside wall of this, right? And there's friction, and they're moving the car. Therefore, you can determine which way the car is moving and which way the engine is moving, and the car as well. So it must be moving this way, like this. Clockwise, right? Because here's the thing now, which is really cool. If you actually stop the engine, or it goes slower, and this part is going faster, then it's actually turning it the other way around, like this. So let's say the engine is turning this. The engine is moving. It's forcing these things that way, like that. So they're forcing it upwards. Remember, this cage here, it won't go that way. So if the engine is turning this way, no, it's forcing these rollers upwards. It's hard. Once again, it's hard to. Hopefully, you can, guys. It's much easier to understand this through visual analysis. Okay. But my explanation is good here. But now, at the point where it's you let off the gas, okay, the engine goes to an idle. Now the engine speed is lower, but the car keeps moving at that speed. So now this here is actually moving slower, and this one is this other one here. This part, let me get the name here. Fuck is good. Ring gear. Okay. The ring gear now is overrunning it, so it forces. It's going like this now. Remember, they were going together that way. Sorry, this way. See? They're running together that way. Now the engine is like slow, or let's say it's actually stopped, just for the comparison. Now this guy is going faster. It still keeps moving, remember? So it's going to force it that way, which is going to force it to go down. You see? It's up. Now imagine that this here is right in front of it like that. And the turning motion of it is forcing it downwards like that. Which means that now these two are disconnected, and the drive shaft of the car is completely disconnected from the transmission. Which means that the car will freewheel, it'll coast without the need to put it in neutral. Right? You just let off the gas, the engine speed goes down, and then if you want to drive the car again, you just hit the gas again, and this starts to turn fast again, which causes these things to go outward again. They touch the inside of the ring gear. Once again, there's friction. You see? Imagine my hand is the ring gear there. Right? Stop the engine. The ring gear keeps spinning. Remember, now they're both spinning this way, for example. Here's the ring gear, both spinning this way. And I stop the engine. The ring gear now keeps spinning these, and it pushes this way. See, it's following the direction of the ring gear. Right? So there you go. Now that's a way you can determine the speed of the car. If I try to do it the other way around, then the engine would just see, if I went that way, then it would just force it inwards like that, and there wouldn't be any contact. You see? So this here is actually carrying this little cage here, and it's it's not really thick. It's 1/8 thick steel, but it's really high grade. It's also carrying the weight of the car, right? So I guess that's the first part. I guess how the clutch cam. I guess that's what sometimes they call it different names. 15, 17. They call it clutch rollers. I don't know why clutch, but not really a clutch, but okay, clutch rollers. Okay, that's how the clutch roller works. And once again, this is regardless. The key here is that this is automatic. That's why this transmission, it's basically automatic, because it's regardless of which speed you're in. If this here is turning faster than the ring gear, then the rollers, the little bearings, little cylinders, they're forced outward. Now it could be 5 miles, it could be 5 kilometers an hour, it could be 50. Doesn't matter. As long as this speed is higher than that one, it'll tend to overrun it, if you will, and it'll force those things upward. The minute this here, the ring gear, is turning faster, then it's actually turning, essentially in the reverse direction. Then it turns this way, which causes all the little bearings, all the little rollers to go in. All right, so essentially, I don't normally do this, but I'm going to tell you guys right away. A little cheat. The overdrive is actually only this piece here, okay? This is what the overdrive is. Now soon we're going to talk about the size of this, and it's a little more complicated, but like the speeds and how they work, but this is the basic working principle of this. This clutch roller, fuck, I get all fucking messed up.